want to tell the whole story, and I think it's my nature to do that with data, to show you what the data tell us about fire and climate change in California. So let's get to the bottom of it. This talk is entitled California Fire and Climate Change, What's the Connection? So recently, on September 15th, 2020, the LA Times proclaimed that this is the worst fire season ever, again. And I think a lot of you know exactly what they're referring to. This year, we've had a number of intense fires, starting off with fires across the state, but Southern California had the large Bobcat fire. Some of you are probably familiar with that, near Pasadena. We also had the largest wildfire on historical record, which is the August Complex fire. And that burned over 1 million acres. It was the first 1 million acre fire. Here you can see it in Northern California, near north of Sacramento. That was a big wake-up call for many people. And it wasn't just this one. There were actually a number of the largest fires in California history that have occurred in 2020. 5 of the 6 largest, to be exact. So here you can see the location of the Bobcat fire, and up here the August Complex fire. But there were numbers throughout the Sierra Nevada. There were coastal fires that burned redwoods on the central coast of California. You can see we're now at over 4 million acres burned, about a quarter of which was the August Complex fire. But this is by far the highest, the greatest burn area of the historical period in California. And you can see the lead up to this is increasing burn area, average acres burned per year, from 231,000 all the way up to this year with 4 million. And we're not done. The fire season is still going. 2020 is still here, fortunately. California wildfires, here we hear from the LA Times on October 3rd, on the cusp of 4 million. And of course, we are far past that now. But this is nothing new. So many of you will remember fires in our local area, the Thomas Fire in 2017, which was a massive fire that burned in Ventura County and Santa Barbara counties. The Woolsey Fire, the tragic fire that affected areas near Cal Lutheran in the Conejo Valley and down to the Malibu coast. But this is just part of a larger trend that we have seen in fires since I was born, since during my lifetime. So if we go back to 1972 and we go forward to 2018, we can see there's been a 5-fold increase in land area burned in California. And here it's broken down into regions: North Coast, Sierra Nevada, Central Coast, and South Coast. But if we look at the overall trend, it's a 500% increase through 2018. And of course, this does not even include, the massive acreage burned in 2020. And here we are. This is the historical graph showing from 1950 to 2020. And you can see in total acres burned in California, we did not surpass 1 million until the last 20 years or so. And we've definitely accelerated well above that. You can see 2020 by far the greatest burn area on record. And it's not just California. The 2 largest wildfires in Colorado wildfire history are burning right now as I make this presentation. So it's not just a California issue. How far beyond California does it go? We know that wildfires are more frequent in the Western United States. Again, going back to 1950, we see this big upswing starting in the 80s and this trajectory going through 2017 in this case. And this is the number of large wildfires. So these are fires above 1,000 acres. And again, we can see this upturn. This one starts in 1970, going through about 2016 or so here. So California wildfire acreage burned from 1987 to 2020, the year I graduated from high school, until today, has been on a steady march upward. And the question is why? A lot of people are pointing fingers. There are lots of ideas about what has caused this, and I want to try to get to the bottom of that. It's not limited to California or the Western United States either. This is something that we see going on globally, and it's something that we see on several different continents. So you'll probably remember that in 2019, the Amazon was in the news for burning. And some of this was largely driven by human burning and human causes and forest clearance and political will to do that. But there are other reasons for global fires as well, which I'll touch on, including climate. Here you can see fire in this part of the Amazonas state in Brazil from 2004 going through to 2019, the highest fire year on record. And fires were burning throughout the Amazon and beyond in South America last year at a much greater rate than they normally do. Siberia also was affected by major wildfires in both 2019 and 2020. And one thing we know about Siberian fires is that there's a lot of tree biomass up in that area, just like in the Amazon. And when these fires burn, they release carbon dioxide. And in this case, we can see with this image that they're releasing carbon monoxide, which can be picked up by satellites and show just the global effect all the way over into northwestern United States. Areas were affected by this carbon monoxide and the associated aerosols and particulate matter that come along with that. So we know that the Siberian fires, for example, were caused primarily by aridity. We can see the temperature anomaly, extremely high temperatures over Eurasia. In this year, we can see in the 2020 fires, and a strong tie-in with the Siberian fires of 2020. And we've seen them in both years, successive years in Siberia. So climate change is a big part of that. We're looking at temperature anomalies there, and this is just a recipe for wildfire. When you have more heat, when you have higher temperatures, it leads to more fire. It also leads to drier fuels. Australia was the other place that was in the news, and their wildfires, of course, were happening during their summer season, our winter. So December and January of last year, much of Australia was burning, especially on the East Coast. And you can see the scale of that. It's kind of like seeing fires across the entire, would be like seeing fires across the entire United States. And although the Australian wildfires have dwarfed the Siberian fires and the Amazonian fires, and yes, the California fires of 2018, which was the greatest fire year on record until this year, this is really showing a pattern across the globe of climate-driven fires. The Earth is warming, and if we look at the data from Australia, we can see on the left side, this is a temperature record, and going through 2020, and it's showing that the highest temperatures on record were felt in Australia in the lead up to the fires. You can see in this burnt orange area, all these areas experienced record high temperatures, and at the same time, record low precipitation. So we have the highest temperatures on record, and the lowest, here you can see over here, the lowest precipitation on record. So those two things combined, of course, led to massive wildfires because the fuel conditions were right. There was enough dry fuel and enough aridity to carry those fires. So I want to touch a little bit on my own personal journey with wildfire. I don't think I thought much at all about wildfire until 30 years ago. In 1990, I was a student at UC Santa Barbara, and we saw some smoke in the hills behind Santa Barbara that got closer and closer and closer. And here is UC Santa Barbara, and here's the Santa Barbara coastline, Goleta. Here's the Painted Cave fire. It started up in the Painted Cave region in the mountains above Santa Barbara, and it moved downward, downslope, and it actually came all the way down and jumped across Highway 101 and started to burn into Hope Ranch. Some friends of mine and I, we rode our bikes down, and we saw horrific scenes of completely burned out houses and cars that were had their tires melted and were completely burned in the streets. And this really left an impression on me. And here you can see where the Painted Cave fire jumped the 101 highway, and which was unheard of. If 101 is not a big enough fire break, then what is? So the question is, was that fire and these other fires, are they inevitable? Is climate change meaning that these fires are coming no matter what, and until we get a hold of or get a handle on climate change, we're not going to be able to have much of an impact at all? And I think that's an important question. Does human agency play a role at all in trying to thwart future fires? And I thought a lot about this at graduate school when I was at Berkeley. My advisor, the late Dr. Roger Byrne, and Scott Mensing, a colleague of mine who's now at the University of Reno, along with Joel Michelson at UC Santa Barbara, published this paper when I was in grad school in 1999. And what they said was they looked at fire in the Ventura, Santa Barbara region, and they said climate is the overall driver. They basically looked at sedimentary charcoal records in sediment cores in the Santa Barbara Basin sediments and elsewhere in terrestrial settings, and they found that that no matter what impacts that people had on fuel loads, etc., that it was actually climate was the overall driver. That precipitation and temperature and things like Santa Ana winds, which we're actually experiencing right now, were also a major driver. And this has been echoed by others working on this topic. So here you see a paper in the Proceedings of the National Academy of Sciences, and you'll see several of these today, one of our most prestigious journals in the United States, and they show a very strong relationship here between fuel aridity and forest fire kilometers, total hectares burned in the Western United States. So as aridity goes up, so do forest fires. That would make sense. So there's a strong correlation with total burned area. And we also know that short-term weather phenomena can accelerate fire spread. For example, the Santa Ana winds that we're experiencing now and that we experienced last year, along with fire in the fall, are a natural phenomenon where high pressure develops over the Great Basin with relatively lower pressure offshore, and a very strong pressure gradient drives these strong winds, these offshore winds, and along with it, they can push fires at a much greater rate. The spread of fires is much greater during these events. So if we look at the fires of this year, we know that we've had an historic heat wave. We know that on September 6th, for example, we had one of the hottest day on record in Los Angeles County, with Woodland Hills reaching 121 degrees Fahrenheit. And not much earlier in the season, we also had record temperatures in Death Valley, and you can see this heat wave that was happening in early September. And this is showing the record high temperatures all throughout the state of California, and going into neighboring states of Arizona and northern Mexico. So these heat waves, like the one we experienced this year, are actually on the upswing. If we look at extreme heats, days above 100 degrees, we can see the historical mid-century and late century numbers, and everything is going up. I mean, look at Riverside County here. Historically, it had been about 4 days a year above 100 degrees. And now in recent years, it's 31 days above 100 degrees. And we're seeing more and more everywhere across the state is increasing. And so the number of heat waves per year is up from 1960 to 2020. The duration and the length of these heat waves is increasing as well, ever slightly, and the intensity also has a slight uptick. So climate change is increasing extreme autumn fire conditions, that's for sure. We're having more fires, not only in the summer, but going into the fall. And that is definitely what we're seeing in this graph here. So if you look at, this is showing temperature statewide, increasing temperatures from 1980 through 2018, decreasing precipitation. So this is not something that we would always expect with global warming, for example. Precipitation with global warming, you increase evaporation, and actually precipitation increases globally, but the geography of that precipitation can change, and we've been on the wrong end of that. And California has been becoming drier and drier in terms of precipitation as temperatures have gone up. And that's made for what we call fire weather. And fire weather incorporates precipitation and temperature and wind patterns, etc. So the two biggies are temperature and precipitation that are driving fires. We also know that California, and this is another article here in Science, another prestigious journal, that points out that the last 20 years, or the last 19 years, from 2000 to 2018, which is the years that they of record on this study, that it was the second driest, here we can see over here, the second driest 19-year period in history over the last 1,200 years. So of course they're going back and using proxy data, mainly from tree ring records, but they can we can reconstruct these how this aridity fits into these longer term records. And this is consistent too with global records of global change. So here you can see the global climate record of temperature going back to 1880, looking at the long-term mean. So where do these temperatures fall around the long-term mean? And we can see since the late 70s, just before 1980, we've been on a really steady march. After a fairly flat few years where we had neither warming nor cooling from about 1940 to 1980, we have been on a steady ramp up. In fact, most of the hottest years on record have occurred in the last decade, 9 of the last 10. And if we look at California, average summer temperatures are up significantly. And this is showing the California data from the 1890s to the 2010s. And what we see here is that, and this goes through 2017, is that we're seeing more than a 3-degree Fahrenheit increase. So we go from roughly -1 below the long-term mean to about +2 above the long-term mean over recent years, just since over the last 20 years or so. So this has been a significant acceleration of warming in California after, like I said, after some period of cooling in the 40s and 50s. So does climate change alone explain the recent increase in wildfire in California? And I think that's a reasonable question. And I would say no, it's not just climate change. Climate is the primary driver, but there are many other factors, and I want to go over a few of those with you today. So this is basically showing the percent of human ignitions of all wildfires in the United States. So in the Western United States, in this sparsely populated Western United States, ignition by humans is low. It's 20 to 40% in this region. But human ignition in California, especially in the coastal areas, is more in the range of 80 to 100%. There are some places in the Sierra Nevada where lightning strike fires are significant, but in general, most of these fires are started by people, and you can see that here. Human ignition is dominant. And we hear when people want to point fingers at who's to blame for all these fires, a couple of years ago it was PG&E. PG&E is the problem. It's the power lines. Yes, the power lines are a problem, but to say that it's one issue and to ignore The other causal mechanisms, I think, would be naive. And then this year we've heard about this gender reveal party over and over again. It's been in the news. Someone accidentally set this fire. Yes, that was not a smart thing to do, but no, these human ignitions are not driving the fire. They're playing a role. And if you don't have people in the area to light these fires, then of course they're not going to get started. But we have 40 million people in our state. So I want to think about climatic versus anthropogenic drivers of fire frequency in burned areas. So what's the relative influence of human activity? So that's the anthropogenic versus just climate change that's happening, also caused by humans, but something that we have less control over. And this brings me to my own work. And back 10 years ago, in 2010, I published a paper, and then I published 2 more papers in 2011, co-authored papers on fire in the New World, in the Americas. And I really focused, most of my research is in Central America, so I focused on the American tropics. But we found, and we argued, that abrupt land use change, you can see it here in the title, abrupt land use change played a role in causing a decrease in fires and fire frequency and spread after the arrival of Europeans in the New World. Why is that? Well, I'm going to give you the punchline here, and I don't have the best data. I don't have a great graph to show you population numbers throughout the New World during this time, but this one was readily available, and this is just showing in central Mexico that starting around 1520, when Europeans arrived, that the population crashed. And we know that 80 to 90% of the populations throughout the New World were lost to pandemic disease of all things, slavery, warfare, and a number of other issues that caused indigenous populations to plummet. So we did a study, and all these data points are showing the sites that we have charcoal records from, these stratigraphic charcoal records, and all throughout the Amazon and elsewhere in South America, and then into Central America. And some of these are sites that I've worked on in Mexico and El Salvador and Nicaragua. And this is how we do our work. And this was a big study we did on Lake Nicaragua. This is our coring expedition on the Mozzarella, this ferry that we chartered in Lake Nicaragua for a 12-day cruise, and we went all throughout the largest lake between South America and the Great Lakes of the United States, and we took cores at all of these locations in red. And fire history is one of the things we were interested in. Here are some of these cores, what they look like when we pull them up from the bottom of the lake. And we not only have this big boat, we take cores off the side of the big boat, but over here you can see a couple of zodiacs. So we also launch this system off the edge of the boat, the big boat, and from this we can anchor and take much longer cores pounding into the sediments below and getting back thousands of years. So, and here you can see us subsampling from the cores as these come up, and here I am with a number of students that came along with me on this trip. And what we're getting at is we're trying to find evidence for burning. So we're looking at microscopic charcoal and other proxies for past burning in these sediments. And we can quantify these data and try to understand what's happened over time. Keep moving myself around there. So basically what we found is that wildfires decreased in the American tropics after European settlement and the native indigenous population crash. So I'll just point your eyes to this graph, where it goes back about 8,000 or 9,000 years to the present. And you can see there was burning, fairly decent amount of burning in this charcoal index. And then right around 500 years ago, it crashes. And if we blow it up and look at a higher resolution, and now I'm throwing in lakes from Mexico and El Salvador and Nicaragua, we can see again a similar, similar pattern from 1,500 years ago to the present, where we have, variable burning up until about 500 years ago, and then all of these records crashed down. Now, we see in some records they pop back up in recent times, which would make sense, but we definitely see this post-contact decline in biomass burning and wildfire. And we attribute this to a decrease in human populations. So land use practices changed during the colonial period throughout the Americas, and basically people quit burning as part of their agricultural and hunting practices. And most of those fires were understory fires where they would burn to clear out vegetation under the canopy, but they also used fires in the American tropics to clear trees so they could plant things like corn and manioc. So we know that the cessation of Native American burning has also played a role in California. So here is another article that came out in the Proceedings of the National Academy of Sciences in 2016. Alan Taylor at Penn State and others published this article, and they showed, I'm going to point your eyes to these little triangles, that as indigenous populations went down, which are these triangles, so did the amount of burning. And they were using tree ring fire scars. So you can see a higher level of burning here in the 1800s, and then it drops down around the gold rush period, and then it drops way down after 1900 and stays low, even though European populations were going up, or post-colonial populations were going up. So I really want to focus in on this period in California, where we had basically also a cessation of Native American burning practices. So climate and fire have significantly decoupled in California since 1850. We know that before 1850, there was a correlation, a fairly strong correlation between fire and climate, and there were plenty of people out on the landscape to provide the ignition when the climate conditions were right. And they stay together 1600. You see it's very coherent, where you have the fire index in orange, and the climate index in blue, and everything holds together really well until about 1900, and fire drops off and climate continues to keep warming. And this is a really significant time period. This has become known as the period of fire deficit in California and the American West, where we're having fewer fires than what would be expected if climate alone were explaining our fires, which through much of history, that's been the case. And if we look at a record, this is Jennifer Marlin and her group and their modeling of fire using, again, stratigraphic charcoal records across the American West, going back 1400 years to the present. They even try to work in population down here at the bottom. They also show that there is a late 20th century fire deficit, that fires and climate pretty much are in agreement until about 100 years ago, and then things get wacky. And this is what's been going on in California. We have this fire deficit. And what I think the punchline about what's happening now is we've reached a critical threshold where that fire deficit is no longer something that we can maintain artificially. So another claim that we've heard in the news and in this election year and recently is that California has had more wildfires than other states in recent years because of poor land management. Is that true or false? Well, I'm going to say it's both true and false, but it really is mostly false because climate is the underlying driver of these things, and none of these changes, and this fire deficit is not unique to California. We just saw the graph that showed that the fire deficit is throughout the Western United States. And not only did we have cooler temperatures, which would predict lower fires like in the 1950s and 1960s, but we had this active fire suppression that began about 100 years ago. There were a couple of historic fires that happened in the American West that really scared people. One of them was in Idaho. And the decision was made by the federal government and state governments that we're going to fight fires. We're going to have wildland firefighters out there to put these things out because they put human beings, human lives, and structures at risk. And this is the same policy that we have had until the present day dominantly. And many of you know this by the Smokey the Bear campaigns that have been put on. Only you can prevent forest fires. We must put these out. These are evil and wrong, and they're a threat. And to some degree, they're right. You know, where human beings are moving into these wildland areas, it is definitely a threat to let fires burn. But we have in this process, we've had an impact on the ecology, and it's reached a breaking point. And here again, you can see the fire deficit in recent years. So we've had a century of fire suppression, of fighting wildfires. Here you can see wildfire fighting in Lassen National Forest in Northern California, almost 100 years ago, 1927. And this continued, and more people were hired for this, more and more resources were put towards this through time. And now fire suppression is the norm all over the United States. And we have more modern techniques to do this, and we're spending ever more money on fighting fires. This is 1980 to 2017 or something. The cost of fighting fires in California is now surpassing, in some years, $500 million. So what's been the ecological impact of fire suppression? And I think that's something that's worthy of discussion as well. If we look at this record here, or if we look at this image here, we can see that what is causing these big crown burning fires is not the fact that we have large trees and forested landscapes and that we're not cutting down enough trees. It's this understory. It's the dead stuff and the young trees and brush that grows underneath the canopy that has created what is known as ladder fuel, this fuel that can actually bring the fire up to the canopy and eventually eliminate the entire forest canopy. And part of that is dead trees. You can see here tree mortality in 2017 in California. You can see the number of dead trees per acre going through the Sierra Nevada and up into Northern California. And tied in with this has been an epidemic, really, of bark beetle. And bark beetle has been around. You know, these are native. These aren't introduced species. Many of these are native species found throughout the Western U.S., but they've actually thrived as temperatures have increased with global warming. Bark beetles have taken advantage, and they go in and they basically kill trees. And then we have standing dead snags, standing trees. And this is showing a map of the percentage of trees seen with damage from bark beetles across the Western U.S. And in some places, look at Southern California, some places it's between 50 and 100% of the trees are damaged by bark beetles. And that's significant because you have dry fuel, extremely dry, dead fuel sitting at the surface. So how can fire management play a role here? There is some truth to this, that fire management has not lived up to the potential of better forest management. We're not doing the best we can with fire management. And what could we be doing differently? So a suppressed fire basically builds up fuel in the understory. When you have no fire, when you put out every single fire, you get some dominance, but you also get overcrowding of stems. All of these young trees are growing in between the larger trees, and lots of dead fuel on the ground. So now when a fire starts on the forest floor, it can make its way to the surface through these ladder fuels. And then you get the loss of the entire forest, or big swaths of it. Over here, you have an ecologically managed forest. So the understory is cleared out and the dead trees are removed. Now you can use prescribed burns to burn off some of the smaller dead material underneath, much like what the native Californians did before the arrival of Europeans. And it creates a healthy forest where the entire forest canopy is not consumed by each and every fire. So we've been hearing that, you know, with this call for more better management, is that we need to do more logging, and the problem is California's environmental laws. And I would say that's not the case at all. We need to keep our old growth forests. Those old growth forests maintain cooler temperatures and keep away evaporation from the forest floor. What we really need to do is get after these ladder fuels, all of that stuff growing into the understory that can then light these large trees. We know by the persistence of trees like the sequoia dendron in Sequoia National Forest and that area, and also the coastal redwoods, that some of these massive old trees have survived 1,000 or 2,000 years of multiple burns, and they continue to grow. The answer is not to cut down these largest trees, and of course we don't go after the redwoods and the sequoias, but even large pine trees and fir trees should not be the target of better management. It's really the understory fuels. So what should we be doing? We need to take forests that look like this and make them look like this, and we can do that mechanically by removing stuff like you see here. And we can also do that from prescribed burns. So here you can see, and prescribed burning, if it happens in the right time of year, can really be well controlled. You don't want to set these during a historic drought or an historic heat wave, because of course they'll get away. But these can be set at times that are more moist otherwise, in order to clear out and clear the understory of these forests around, especially near humans. And that brings me to the last kind of point of this talk, and that is that another reason that we've had an increase of fire is that we're actually moving into wildlands at a much greater rate than ever before. And of course that's necessary because of our growing populations, or I shouldn't say of course it's necessary, it's been a logical outcome of our increased urban and suburban sprawl, but it definitely comes with costs. I mean, we see houses advertised, backing up to a green area and that kind of thing, and many houses back up to green areas in California. And what we know is that that there are lots of areas in California that were within 1.5 miles of housing, dense housing. So you can see all this blue is wildland area that is in close proximity to housing developments and ignition sources. And that can eventually lead to more of this, like we saw in Paradise and elsewhere over the last few years in California. In fact, if you look at wildfire and this wild urban interface, that is where wildfires happen within urban spaces or suburban spaces, we see that California has a higher percentage of burned area within the wild urban interface than any other state in the West. And guess who's number two? Colorado, and they're experiencing tremendous wildfires right now, and of course putting lots of structures at risk because of that. This is again another study in PNAS in 2017. So as I get to my final thoughts on wildfire, and I know I've thrown a tremendous amount of data and a large number of graphs at you and maps, I want you to really think about this this final kind of parting thought, and that is that fire begets fire. The more large fires we have, the more large fires we're going to have in the future, because you basically degrade these forests to such an extent that the propensity for more fires to burn in the future increases. And on top of that, as we have more wildfires burning, there's more carbon dioxide being emitted, which causes more global warming. That is a climate fire feedback. So we need to have better management because it doesn't look like we're going to get a handle on global warming or climate change from human beings in the coming decades. So we actually are going to be more reliant on forest management and human interventions. And this is just showing the California state wildfires, the number of metric tons of carbon dioxide that were emitted. I mean, this is rivaling automobile emissions and going forward this year. So it's becoming, at times in a bad fire year, our carbon emissions from wildfire can be very significant in the state. And there's also this, and I just learned this, I didn't know this, but there's been an uptick in lightning in recent years that some believe is likely associated with climate warming. That is, as we have more climate warming, we get more dry lightning in the West, and this is showing number of large lightning caused fires and acres burned in the West from 1980 going forward. So we may well be getting more ignition from lightning as well. So this is another issue to contend with as we continue to try to find consensus across the globe to deal with climate warming on a global basis. So the summary: California fire and climate change. Well, California is getting warmer and drier. This is the last graph I'm going to throw at you. And it just shows the years 2000 to 2017 and 2018 in red, and how they compare to the long-term averages before that, the 100 years before that or so. And what you see is that average temperatures are up. You can see all of these gray dots and the red dot are falling above long-term averages. And precipitation here, that's the long-term average precipitation. Precipitation is generally down, and this is a recipe, a climate recipe for disaster for us. So no matter what we do with forest management, we're going to continue to see more fires as long as climate warming continues to affect California, as it probably will in the foreseeable future. So some people have tried to quantify the amount, the extent of this fire increase and how much of it should be attributable to climate change versus fire suppression and other human management issues. And you can see that climate change has become more and more important as time has gone on, whether it's 50% or under that, as this study from PNAS from 2016 implies. Is I don't think it's clear, and this is just one modeling, but I want to point out that climate change and increased aridity is our #1 threat and the #1 cause of forest fires. But we also have some other human impacts that aren't related to anthropogenic climate change, and those are fire suppression, beetle outbreaks and fuel buildup, inadequate fuel reduction, and then this greater risk to homes because of encroachment on the urban wildland interface. So I know that we've had a whirlwind today, and I want to thank you for listening, and I look forward to questions when the time comes. Have a great day, and we'll see you soon. Oh, last image, these beautiful sunsets that we had last month here on the coast of Oxnard because of particulate matter in the atmosphere from fires. All right, be well.